Hello my friends. Today is December 10 and we are ready to open a new problem from LeetCode for our Coding Advent Calendar. In the end of this video, I will also ask popular AI model called GPT to solve the same problem. Stay tuned to see who wins, human or machine. Let's start. Here is today's problem. Maximum product of splitted binary tree. Given the root of a binary tree, split the binary tree into two subtrees by removing one edge such that the product of sums of subtrees is maximized. Return the maximum product of sums of two subtrees. Since the answer may be too large, return it by this module. Okay, so here is example. We have this tree here, and if we remove this concrete edge, we get these two subtrees. The sum of this subtree is 11, the sum of this subtree is 10. By multiplying them, we get 110. We will not get any better result by removing any other edge here. So we just need to find this 110. Here, in this example, we have to remove this concrete edge, because in this case we get the sum of one part of subtree is 6, another one is 15. By multiplying them, we get 90, and we will not get any better result. So how are we going to address this problem? First of all, I offer to calculate the total sum of all node values in a given tree. What this will give this to us. Next, we can consider every node from bottom to top, and we will consider removing every single edge. By removing this edge, we will split our tree into two parts, and we can keep track of sum of values of some subtree here. We will remove its sum of its values from total sum, and we will get two operands to multiply. By multiplying them, we will get some value, and we will keep it maximized. I mean, we will track the maximum value of it. That's the result we are going to get. So let's do this. First, we need to create a function that will calculate the total sum of all values of all nodes in a tree. Okay, if a root is null, then we return null, 0, right? Because sum of values is 0. In other case, we will take current value plus binary recursive sum of left and right subtrees. Okay, that's our function to get the total sum of node values. Let's do this. Let's calculate the sum. Okay. The number of nodes. Okay, it should still be in integer. Next we need to calculate we need to create some function which will be executed recursively, and we are going to somehow get our result. Let's do it like this. A private function which will return something, and we will call it max product. And we will pass our total sum. What are we going to do here? We need to track two parts. So this function will go down the tree, down to leaf level, and it will create many stack frames. And these stack frames at some point will fold back. So the whole thing will be implemented at that point. So by folding our stacks, we will collect all the information from down to top. So first we go down from top to bottom, and then we go back. So when our recursion calls will be folded, let's say. So first, if our root equal to null, we will return something, right? Let's decide what actually we need to return. So obviously we need to somehow track the max product, right? And we decided that it should be long, not integer. And also we need to somehow track the sum of subtree, which is under the current node. So basically we need to return two things. In order to do this, I will do this. I will return tuple, and I will call this part, and I will call this part subtree sum. So if we are on a leaf level and we go deeper, we can return 0, 0, because if we cut it, edge which does not exist, we will multiply 0 from one side by the total sum of other side, and as a result we get 0. And also subtree sum at that imagining level is also 0, so it's correct. Then we are going to calculate this max product for each particular node for both parts, both left and right subtrees of current tree root, of current node. Okay, var left equal to max product root left, and we will pass total sum, and we will do this for right. Okay, so we get 4 values here, because left and right, they consist of 2 values everyone. Also we need to calculate the current subtree sum, right? And it is root value plus sub3 sums from left part and from right part. Okay. Now we will do the following. We will imagine as we cut the edge above the current node. That means we remove this sub3 sum from our total sum, right? We get two operands which we will multiply, and by multiplication we can exceed the integer, so we are going to use long max product current long total sum minus sub3 sum multiplied by sub3 sum. This is our max product current. And now we have three values. We have current max product current, which is calculated based on idea that we will cut the edge above the current node. But this node has also two connected edges, left and right. So we have max product current from left and max product current from right. So from all these three cases we need to pick only one. Okay, let's do it like this. So we calculate the maximum of all three values and we will return it. And sub3 sum. Let's try. Okay, yeah, we forget to call this long and from this point we only need one value. We return tuple and we only need the first part. And we need to convert it to integer and take a module of like this, right? Yeah. And that's it. Let's run. Okay, case 1 done, case 2 done. Let's submit. And it's done. Okay, the time complexity. The time complexity here is big O of n, because we go through all our nodes twice. First time when we calculate total sum, second time when we do the rest. The memory consumption is big O of log n, which is the high of the binary tree. But this binary tree can be non-balanced, right? It can look like this, so in worst case it will be big O of n as well, right? Okay, so CPU big O of n, memory big O of n. Let's do one more interesting thing. There is a popular AI trained model called GPT, and let's ask it to solve this problem for us. Well. Yes, it is the same solution actually. It is the same solution. Not bad, AI, not bad. Well, I would say 1-1. Nice job, AI. For the protocol, robots, I was always on your side. See you tomorrow, both humans and robots.